Hi guys, today we are going to identify the relative maximum and minimum values of a function as well as the absolute. So right here I just have the definitions written out for us. So an absolute maximum is the largest value of the function. An absolute minimum is the smallest value of the function. But a relative maximum and a relative minimum, they are just where the function is higher than adjacent values or values nearby it. And a relative minimum is just where a function is smaller than adjacent values. So if you look at this graph right here, down here, this farthest point here, that is the lowest y value of the function. So that is your absolute minimum. And when we talk about the value, it's the y value of the function. So whatever value that is your absolute minimum value. So let's say these count by ones, 1, 2, 3, 4. So that's a negative 11. So the absolute minimum is negative 11. Okay, and then the absolute max is the very, 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 very highest, which is way up here. That's your absolute maximum. So whatever that one is, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So the absolute max is 9. Okay, so remember these are y values. So all these maximums here, this is the y value. Okay, so then the relative min and max is, I call them the peaks and the valleys. This is a maximum, but it's relative because it's relative to all the values by it. The values right to the left of it are a little bit smaller. The values right to the right of it are a little bit bigger. So right there is your relative max, whatever that is, like 8.5 maybe. Okay, and then up here, this is also a relative minimum because, sorry, also, that's not the same, but this is a relative minimum because the values right above it are a little bit higher. Okay, so this is a relative minimum. In its area, it is a minimum value. And down here is also a relative minimum. It's your valley. To the left and to the right, the values are a little bit larger. Now, here is where students get a little confused. They want to call this a minimum, but it's not. This is called a saddle point, actually, and you don't need to know that right now, but that is not a minimum or a maximum. Okay, so let's move on over here. So here's just another graphic to show you that same thing. Another name for relative is local. So you might see local. This is the same thing as relative max or min, okay? So we have a local maximum or a relative maximum at this y value here and also that y value there. And there is a local minimum down here, and this one's a saddle point. Now, I don't want to say that there's absolute minimum yet because I don't really know what's going on with this function. Like, there's no arrow, so does it stop? If it stops, then I guess this is an absolute minimum here. Now, a good question is, you can be a local maximum as well as an absolute maximum at the same time. So this point is the very highest of our graph, so it is the absolute highest. So it is our absolute maximum, but it's also a local maximum because relative to this little area, it is a maximum. So what kind of problems you're going to see on Delta Math today is how many points on the graph are a relative maximum? Okay, so I mean, it's literally that just 1, 2, 3, how there? There is just the 1, B, that is your local relative maximum. This guy is not, that is a saddle point. Okay, and there you have it. So you'll do a few of those problems to just get an idea of those max and mins.